All right, my pre-cal pumpkins, we are now going to start the examples at the bottom of page 1 of your notes, and we are going to make a connection between our right triangles and our trigonometric ratios that we talked about in our last video. So I want you to notice when we're looking at these examples, these first two, I'm telling you to find the exact value of the trigonometric functions of theta. And of course there are 6 of them. If we're told to find all of them, we're going to find sine, cosine, tangent, and their reciprocals. So when I use the words exact value, this means no rounding. So that means if I have a fraction as my answer, I'm going to leave it as a fraction. So let's look at this first right triangle. As you can see, 17 is the measure of the hypotenuse. It's the longest side and it's across from the right angle. 8, of course, is the short side, and then the other leg is 15. Notice where theta is. The orientation of theta is very important when I'm finding my trig ratios. So if you will recall from the last video, I'm going to use SOHCAHTOA here to guide me in writing my ratios. So I'm going to start with sine. So if you will notice where theta is, I'm going to switch colors here. If you'll notice where theta is right here, the side opposite that angle is 8. That's the opposite side, and the adjacent side is 15. The orientation of angle theta is very important because where that is going to determine what these look like. Okay, so I'm going to start with sine. The sine of theta, if you'll recall, is opposite over hypotenuse. So the side opposite is 8. The hypotenuse is 17. Remember, exact value. I'm going to leave it just like that. Walk away. The next thing I'm going to do is find its reciprocal. Well, the reciprocal of sine is cosecant. So I'm just going to flip that bad boy around. So 17 over 8. Easy peasy. All right, now I'm going to find cosine theta. Cosine theta, remember, is adjacent over hypotenuse. So theta's right here. The adjacent value is 15. So I've got 15 over 17, which is the hypotenuse. And then the reciprocal is secant theta. So I'm just going to flip that around. And then that brings me to tangent theta. Remember, tangent theta is opposite over adjacent, so theta's right here. Opposite is 8, adjacent is 15. And then I am going to find cotangent theta, which is just the reciprocal of that. Yes, it's that easy. Magical, isn't it? I know. It's neat. Okay, so let's look at our second example. This one actually I meant to change and I just didn't do it. So we're going to change this a little bit, but don't freak out. All right, so I'm going to change this to a 7 and I'm going to change the 8 to a 2 just to make our values a little bit easier to find. Okay, now the thing that's different about this problem is that I don't have my hypotenuse. I don't have that third side, so I'm going to use the Pythagorean theorem to find it. So I'm going to let the hypotenuse be c since it's the longest side. So I know that a squared plus b squared equals c squared. So 7 squared plus 2 squared equals c squared. So that's going to give me 49 plus 4, so 53. So the hypotenuse here is the square root of 53. Kind of ugly, but, you know, we'll live. All right, so I've got the square root of 53 right here. Because there's a square root, this is going to get ugly, so I'm just giving you a heads up. All right, so let's start with sine. So sine theta. Notice where theta is. It's this angle right here. So the side opposite is going to be the 2. And the hypotenuse is radical 53. Now, as you know, it is not good math practice to leave a radical in the denominator, so I'm going to rationalize the denominator. And we've done this already in class before. remember that multiplying a radical by itself will eliminate the radical. So sine theta is a little ugly, just FYI. All right, now the reciprocal of that is cosecant theta, and since we started off with 2 over radical 53, it's just going to be radical 53 over 2. Since the radical's in the numerator, I don't have to rationalize the denominator. Life is good. Okay, the next thing is cosine theta, and that is going to be adjacent over hypotenuse, so the adjacent side to theta is 7, and the hypotenuse is the radical 53. Again, I'm going to rationalize this. Oh, man. My handwriting is so slappy sometimes. It's so embarrassing. Okay, now the reciprocal of that is secant theta. So that's going to be radical 53 over 7. And then, of course, we look at tangent theta, and tangent is opposite over adjacent. So opposite is 2, adjacent is 7. Groovy. Cotangent theta, flip that around, 7 over 2. Easy peasy, lemon squeezy. Okay, so how are we going to do the next set of problems? These are a little different. Use the given trigonometric function value. So I've given you that cosine theta is 2 over 5 here, and tangent theta is 1 over 4 of the acute angle theta to find the exact values of the 5 remaining trigonometric function values of theta. Okay, so what you're going to do here is you're going to use your knowledge of SOHCAHTOA to build your right triangle and find the other 5 trigonometric ratios. How are we going to do that, Ms. Griggs? Well, I am just going to draw a right triangle. It does not have to be to scale. Cosine theta is 2 over 5. Well, we already know that cosine theta is actually adjacent over hypotenuse. So that means that wherever I put theta, I'm just going to put it right here. I know that the adjacent side is 2 and the hypotenuse is 5. Now, could you have drawn it the other way? Absolutely. We're not drawing these to scale. We're just doing it to orient ourselves so we can find the other 5 trig ratios. Okay. Now that we've done that, we have to use the Pythagorean theorem to find the other side. So 2 squared plus whatever this is, I'm going to call it a squared, equals 5 squared. So I get 21, so A is radical 21. All right, so having said that, now I can find the other values. So secant should be really easy because it's just the reciprocal of cosine, so it's 5 over 2. And then sine theta is going to be opposite over hypotenuse, so it's going to be radical 21 over 5, just like that. And then cosecant theta is going to be 5 over radical 21, and of course we don't want a radical in the denominator, so that's going to be 5 radical 21 over 21. And then tangent of theta is going to be opposite over adjacent, so that's radical 21 over 2. And then of course cotangent is going to be the reciprocal of that. And of course we rationalize the denominator and find 2 times radical 21 over 21. Okay, we're going to do the same thing with tangent theta, but remember tangent theta is opposite over adjacent. And so when we draw our right triangle, theta's here, opposite 1, adjacent here, and then we don't know the hypotenuse, so I'm just going to call it C, use the Pythagorean theorem again. 1 squared plus 4 squared equals C squared. That gives me 17 equals C squared, so C is the square root of 17. All right, cotangent, just flip that around. It's going to be 4 over 1, or 4. Sine theta, theta's here, opposite over hypotenuse, so 1 over radical 17. I'm going to rationalize the denominator, so that gives me radical 17 over 17. Cosecant theta is radical 17 over 1. Cosine theta is going to be adjacent over hypotenuse, so 4 over radical 17. Rationalize the denominator. And then secant theta radical 17 over 4. See? Easy peasy lemon squeezy. You got this.